on your labs, the first thing that was asked for you is to put a name, and that was mostly well done for everybody, but not everybody put a name or research question. But we are going to concentrate on the Excel part now, okay? Anytime that you have a graph or a table, you need a title. Table of results, it's not a title, okay? That's a heading. If you do a completely lab report, like you write aim or research question, you write hypothesis. Table of results is not a title. The title needs to be clear enough that you exactly know, just by reading that title, what it's going to be in your table. Here, in my table, I didn't put the title because it's still the Excel. But when I transfer it to Word, I'll put the title. What I start here putting, and that's how a table should look like, it's proper headings with units in each of my columns and rows. Okay? So I have, for on one side, I have time for milk to travel the 50 milliliters of copper sulfite, and that's in seconds. And then I put an uncertainty. We're going to talk about that in a second. And I avoid repeating trial 1, trial 2, trial 3, trial 4, so I just put it once. Yeah? And all of these is in only one cell, so I've went here and merged all the cells together, because all of this is that information. And on the other side, I have the protein concentration. When you did the lab, you number the tubes 1 to 10 or 1 to 7. But this doesn't say anything to us. We don't want 1, 2, 3, 4, 5, 6. Yeah, we are doing that instead of writing very long in your tubes, but you have a protein concentration. Okay, and the protein concentration was in percent, and I have an uncertainty again. Okay, how do I measure the uncertainty? The apparatus that we are using tell us which is the uncertainty. For a stopwatch, it was giving us 2 decimal places. So the uncertainty of that stopwatch was the 2 decimal places. What was that? Was wrong before. Yeah, and you can look at the stopwatch and see what the person the company that produced it is giving you as an uncertainty. When you have like protein concentration, you use the measuring cylinder, or let's say you're using a ruler. Okay, if you're using a ruler like a 30 centimeter ruler, and it's giving you the smallest lines that is giving you, it's a millimeter. So when you are measuring something, you're gonna go to which of the millimeters that are one side or the other, it's the closest. Or if it's exactly in the middle, you'll go to the middle of that. So it is always, for this ruler that's giving me 1 millimeter, it's going to be half a millimeter, my uncertainty. If I were using the measuring cylinder that was 10 millimeters and every little line was 1 milliliter, half a milliliter is going to be my uncertainty. Does that make sense? Yeah. So for analogic, it's half of the smallest measurement that you have. For digital, it's what the person that has produced that apparatus says. If you are counting yourself, if you are counting people, if you are counting how many jumps they do, you always get 1 as a plus minus. Okay? So I have clear headings with what it is, units and uncertainties. Yeah? And then for each of my trials, I put my data. Remember, we conserve decimal places. So even if you get 14.1, if you're putting 2 decimal places, you have to put 14.10. Yeah? How do you change decimal places? Here, with these buttons, you can change them. Yeah? So, what I've done also was arrange, because you started with a more concentrated one. But it doesn't really make sense to start 190, 70. We always start from smaller to bigger. So when I do my table in Excel, I have my raw data, then I can arrange it here nicely. Yeah? So I have for each of the concentrations the different trials. Now I have to do the mean. We call it mean because an average can be mean, median, or mode. And we are interested in the means. Okay? Excel, however, still keep on calling it average. But when you are doing the mean, you just have to type the formula. So for any formula in Excel, you're going to use the equal. And then, let's do this again. So I want to do the average. And then, it's going to ask me, and then I will have to say from which numbers I want. So I can select from which ones I want. I want from this one, I close parentheses. Okay? And I don't need to do it for each of them. If I change this square that it's white to black, I can extend it and I will have it for all of them, the formula in there. When I do standard deviation, and in the middle school and in the MYP, you did the maximum and the minimum. But now we are learning statistical tests and we said we're going to do standard deviations. Excel also have a formula for it. So you start standard deviation, and you pick the 1.s because that's for your sample. And brackets again, and you want these numbers. Be careful not to include the mean on it. Yeah, you just want your trials and you have it there. This is gonna be used to create afterwards the error bars. Yeah, so we have paid attention. We've sorted from smaller to bigger. We put headings with units and uncertainties. We merge the cells if necessary. We not repeat words. We use the same decimal places, and for the mean, we also keep the same decimal places. If when I do the formula, it gets to more than 2, I have to change it here. Otherwise, I am going to be creating more precision. Yeah, and I only had 2 decimal places, so I keep it 2 decimal places. Yes. Do not repeat words. Don't put trial 1, trial 2, trial 3, trial 4. Chris, sorry, will you go and see me at break tomorrow? Yeah? Okay, good. Because it gets too many information here. Sorry, I had it not properly written and I changed it to not properly written. Yeah? Yes?
You know on the top when it says time to travel 50 milliliters?
Yeah.
You have S plus or minus 0.
Yeah.
Is the 0.01 just showing how many decimal places you're
No.
each number?
Excuse me. Maybe the question that Finton has, it's important for everybody. That is what the manufacturer of the stopwatch that we use told us. Yeah? So for all the electronic apparatus, they have an uncertainty. Yeah? Okay. So, we get in the mean the same number of decimal places. I cannot add precision. If I put now here 3 decimal places, I'm giving 1 more unit of precision that I didn't get with my stopwatch. Okay? In the standard deviation, it's different. Here I keep 2 decimal places because they get already numbers that make sense. But if I'm getting very small standard deviations because I work very well and all my numbers were very similar and I just get a 0.001, then I will want to show that. So the standard deviation can have more decimal places. Okay? It's what it says here. Not in the standard deviation necessary. Okay? And we have created this by using the form because here you only had 10 values, but sometimes you might have 200. So you don't want to write the same formula 200 times. Okay? So that's how a proper table needs to look like. And lots of you tables didn't look this way. Doesn't make sense now. Yeah? Now from here we need to go and create the proper graph. So in the graph, I'm gonna want to compare protein with the mean value. Okay? So if they are not put together, and you can always put two tables, one with your raw data and one where you process the data. If you create a second table, then remember again to put the proper title and everything. Can be, in this one case, it was easier to have it all in the same one. So now I want this data, and if they are not together, I have to use the command key and this data. Okay? So clicking the command D, I could select separate sets. And when I go to charts, if I'm comparing values of two different things, but they are both measurements that are continuous, I'm going to create a scatter graph. Okay? So here is where I go. I have these different options. Normally, I like this one that already gives a line. Sometimes when you do that, if you get some outliners, the line looks not nice, then you could always go to this one and not have that line. Okay? This is not a trend line, it's just the line of joining my points. Make sense? So I have it there. Just gonna put it here for now and try to see everything at the same time. So let's say, okay, if we can see. That's big enough, but we can see everything. Okay, I think we have to go that. All right, so I only have one set of data, so I don't need this. It makes it bigger. Okay. I need to have things nicely again. So I have the chart. Now I can have the chart layout, and I'm gonna put a proper title on my chart. Okay, up, and again I can say that's the time for milk to travel 15 milliliters of copper sulfate. Good. Yes. Yeah, we're gonna go through the unknown in a second, okay? I need to label my axis. So at the bottom, I had what I changed, and that was the protein concentration. And again, I have to say which units. That was in percentage, and what uncertainty. That was plus minus 0.5 due to the measuring cylinder that we use. Okay, and I need to change the vertical axis, and here we had time in seconds plus minus 0.01 because it was what the stopwatch gave. Okay. This, now you're gonna have to redo it. So the video will try. Yeah. Yes.
Can you put time also on the x-axis?
But what did you change and what did you measure? Which is your dependent and your independent variable? We had different protein concentrations. That's our dependent variable. That what we change. So that has to go to the x, and what we measure was depending on what we change was the time. It has to be on the y-axis. So that's always it's in all your guides to write lab reports. Yeah, that makes sense. Otherwise, you get a graph that doesn't have a shape that makes sense. Like here, the more concentrated, the less time it took.
Well, mine had a similar shape, but I had to switch.
Yeah, so you'll have to rechange that because it's always what we change at the bottom, the independent variable, the dependent on the y-axis. Okay? So, what do we do with the standard deviation? We create error bars. In the same place where we put the title and the axis, we have the error bars. And we need to go to error bar options and we need to customize it. Now what it gives here to me as default, it's already what I want. I want it to be up and down, and I want it to be as a cap. And my error bars are for the time, that's what I measure. So I need them Y error bars, okay? Not X error bars. Some of you had the other way around. If you put the data properly, it shows it to you automatically. Otherwise, sometimes here you have X and Y, and you have to select which one it is the ones that you want. Okay, so I go to specific values, and my values is the standard deviation, and my value here, it's also my standard deviation. So I have it there. And to double check, and I would like eventually to make it a little bit bigger, but now we are showing you. They are not all the same, because this first point, I had quite a lot of error, 2%. So I see a big bar there. This one I also had a 0.49, so I see a very small one there. If all of them look the same, you've done something wrong. Okay, so remember, you select the points, you are on error bars options, and you have to customize and put them here. Making sense? Okay, so I'm almost done now. I have, let's make it, the graph completed. Now on all that, you had an unknown one, and you didn't know which will be its concentration, but you measure the times. So you have different times and an average, again, a mean, and an error. How are you going to find that with the graph? What you can do is, if you go to chart and use source data, that's the data that you have. Here we have just this series. I can add my unknown, and I know its Y value. The Y value of my unknown is this one. I don't know the Y value, that's what I'm trying to find. Oops, sorry, the X value. That's what I'm trying to find. So my Y value of my unknown was here. Yeah? So it appears there. I lost, because I took it out before the legend. Now I can say it. Okay? And this, sorry, in here, I can name them. So this one that didn't have a name, that was my dilution curve. And the other one, it's the unknown. Yeah, so I have them here. Okay? This unknown, if I'm on it, the same thing, it has some errors. So I have to customize specific value. This is my error for the unknown. Yeah, up and down. Okay, there I am. Yeah. Yeah, I'm not done yet, Ollie. Yeah, okay. So now you have to find the protein concentration. You have different options to do this. One of it will be, you go once more here and you add a trend line. If we are looking at the trend line, does this look like a linear trend line or an exponential trend line? Exponential. So I want it for the dilute curve. I have here the trend line. Now I can go to trend line options for the dilute one, and what I want is that it displays the equation. I have it here. Yeah, so I have my equation. Oh, sorry, that didn't work properly because I wasn't on top. I have to be on top of the exponential trend line, and then go to the options, and now it's not gonna ask me, and I'll display the equation. Okay, now the equation, because it's an exponential one, will come as exponential. Yeah, so it's gonna be a little bit of math difficulty to use this y here and isolate the e, because you have to apply logarithmics. If you are good at math, you can do that. If you are not good at math, it's what I asked you to do. You print this, you get a ruler, and you get from here to here what you got, or you decide if you want to do it with this one or with this one, and down. In the middle, the ruler and the same, and in the minimum with the ruler and the same. Yeah, you explain if you use the trend line or if you use your dilution curve. But you're gonna get down here 3 different points. Yeah, you're gonna get the middle one is gonna be the average, and the 2 ones on the sides are gonna be the errors. That making sense to everybody? Yeah. Now, if I want to be a little bit specific, because this axis is going every 20, so I will have to kind of estimate it. If I double click on the axis, it shows me the scale, and it says it gives me every 20. Maybe I want every 5, and then I'll be able to see much better here. Yeah, when I get the points, I don't have to estimate between 20 and 60 where it 80 and 60 where it was. I can see much closer. If you apply it here, you can get it with decimal places. Okay. There's probably a way that Excel also does it for you, but I haven't figured it out yet, so I'll have to do a little bit of research how, if I give that number to Excel, it will figure it out for me. But does it make sense to everybody now? Yeah? Because your graph didn't look like this. There was a lot of mistakes with putting the error bars and with finding the values. Yeah? After that, you have to create a conclusion. Your conclusion will be, the unknown sample was on average whatever it was, plus minus whatever you got, the values of the standard deviation. Yeah? Now you have to talk how certain you are about these results. If you have error bars that are like this, not very big, except this one is a little bit big, you might be quite certain. This was Emma's group. She shared the results with me. So they were quite good values. If you have error bars that for the point, 40, it overtakes the 20 and the 60, then it's not very accurate. So how certain you are about the results, it doesn't depend, I think, I work, okay? It's when you look at your graph and you look at your error bars, are they overlapping? These almost overlap, but here seems to be a difference. These almost overlap. These are very close. Is there a difference or not? Yeah? This looks quite as a good exponential curve. So they look pretty good because of all this. The error bars are small, the shape of the graph, everything. And you have to explain. Yeah? And then you talk about limitations of the method with improvements, and it makes your life much easier if you try to make a table. You find a limitation and then you find an improvement. You don't have to, but it's easier to visualize. It's easy for me to correct also. And then it's about the method. This method, we know already there was a lot of things that they didn't work properly. When you put the pipette, the drop could be bigger or smaller. It can go with more force or less force. It was difficult to do. Do I put it in the liquid? Do I put it a little bit on top? Then you have to start the stopwatch as soon as it crosses the first line, and as soon as it crosses the second line. Twice human error, not just because of deciding when, it's because of pressing the stopwatch. So how can this be improved? Maybe a machine that puts the drop, always with the force measure, always with the volume measure. Maybe a laser that says, okay, now it crosses, now it crosses. Yeah? So a little bit of research. Yeah? That makes sense? Okay. So, any questions here?
For the error class, if you have a result that seems unlikely, perhaps it could be just an error in judgment, can you remove?
Okay, you're not gonna remove in your raw data table. You're gonna leave everything, but then in your graph you cannot use it, and then say explain why. Yeah, or you can put it and say that was an outlier, and put two graph, and this one now wasn't used because of it looked very far out of the trend line. Yeah, makes sense.